Hi and welcome to Network Time Protocol tutorial. What is Network Time Protocol? Network Time Protocol is application layer protocol in TCP/IP suite, and it uses well-known port number 123 and UDP as transport. NTP is used for time synchronization among participating network devices with reference to a reliable clock source, either absolute or relative. Absolute means the time source is a reliable time source, that it serves true time or accurate time, whereas relative means that the time source is not reliable. Absolute time sources could be atomic clocks, radio clocks, GPS receivers that receive time from an atomic clock in a satellite. Relative time sources could be our operating system clock. Time measurement is mostly based on change in day and night caused by the rotation of the earth. There is a period during day when the sun is at the highest point, which we refer to as noon. Noon happens at different times at different places, and this gives the concept of local time. Different places on earth have different time zones, and we notice the need for a common universal time when communicating with people located in different time zones. Greenwich Mean Time, or GMT, is one such time where all other local time zones are represented by adding or subtracting hours from GMT, but it is not very accurate. It is based on rotation of the earth, which is slowing down, and we have more accurate methods of measuring time available to us now. So NTP uses Universal Coordinated Time, or UTC. It does not use the Greenwich Mean Time. So NTP uses UTC, and UTC is the official standard for the current time. Greenwich Mean Time was world's standard time, which was replaced as official time standard since it is not as accurate as UTC, which is measured using atomic clocks. Universal means it is guaranteed to be the same everywhere on earth. That is to say, it is independent of time zones. To convert UTC to local time, you have to add or subtract the local time zone. Coordinated means that several institutions contribute their estimate of the current time, and UTC is built by combining these estimates. UTC is based on International Atomic Time, which is an average of the time kept by over 200 atomic clocks in over 50 national laboratories around the world. Why do we need to synchronize time on computers? So effects of inaccurate time in a computer become visible as soon as it is connected to the internet or to a network. You may receive an email on a date and time before it was actually sent if your clock is inaccurate. If you want to map events on one computer to corresponding events on another computer, both must be time synchronized. Debugging network issues becomes difficult if the log files have different timestamps because the network devices were not synchronized. Database transactions related to financial services require highly accurate timekeeping. NTP could also be very important with SAN. Some SAN require accurate time for proper synchronization or file system usage because all the files need to have timestamps that agree. You cannot have timestamps of some files which are into the future. NTP solves this and many other problems by synchronizing time with global reference clocks that define the true time. It uses UTC as the reference time, and it can also estimate current time even when the network connection to the time server is temporarily unavailable. So let us consider three different scenarios in which NTP could be used. So first such scenario is of a home-based computer. A simple NTP setup for a home computer that is connected to internet could be that it gets its time from several public NTP servers. When it boots up, it reads time from the internet or from its real-time clock chip if internet is not available, and then will sync to the NTP server as and when the time is available. NTP is implemented as a daemon process in most Unix and Linux systems, which is known as NTPD, where D stands for the daemon process. Our second example setup is that of a company, of an enterprise. So a company can have a GPS receiver and a dedicated NTP server that gets its time from internet or from a GPS, which in turn gets its time from an atomic clock in a satellite, and it serves time to clients in the network. Here we can see at the second level of hierarchy, which represents network routers and switches, that the NTPD daemon process acts both as a client and a server. As a client, it gets its time from the dedicated NTP server, and as a server, it serves time to other computers in the network, which are NTPD process clients. Our third such setup is that of an isolated network without external time source. Suppose we have an isolated network. In that case, we need to select any one machine to act as a primary server and let clients take time from it. Such a scenario is employed if you don't care about the true time, but if you do care about time, about keeping all the devices in the network synchronized to a common time. Having considered these three example setups, let us understand the NTP architecture. So NTP uses a hierarchical system of time sources. Each level of this hierarchy is termed as a stratum and is assigned a number starting with 0. Stratum 0 devices are atomic clocks, GPS clocks, and other radio clocks. They generate a very accurate signal that triggers an interrupt and a timestamp on a connected computer. These connected computers comprise the Stratum 1 devices. The Stratum 0 devices are also known as reference clock. The Stratum 1 devices, the computers which are connected to the Stratum 0 devices, are also known as primary servers. They serve time to Stratum 2 devices, and Stratum 2 devices in turn serve time to Stratum 3, and so on. Only Stratum 0 to 15 are valid. Stratum 16 is used to indicate that a device is unsynchronized. So now, having considered a brief overview of NTP, let us go ahead and understand the basic NTP client configuration that you can perform on your computer.